Okay, here's the second of 3 videos associated with worksheet number 7, working with rational expressions. The previous worksheet was a sister to exercise 1, which was a problem taking 2 rational expressions and dividing. This problem 2 is or exercise 2 on worksheet 7 is actually a subtraction problem. And right off the bat, my red flags go up because I'm subtracting fractions, whereas there were no flags when I was multiplying and dividing fractions, because that's very straightforward. When you're adding and subtracting, right, it only makes sense if you're dealing with a common denominator. So this problem up here has a smiley face associated with it because I've got the same denominator in both cases, right? So in order to do this problem, I'm just going to sit back. I'm going to recognize I'm really dealing with fractions with polynomials in the top and bottom, but fractions nonetheless. I'm subtracting, so I have to have a common denominator. Holy Toledo, great. I have a common denominator of 2x minus 3. Before I go ahead and do the subtraction, since this is a rational function, I'm going to remind myself x cannot be equal to 3 halves. If you try to put 3 halves into that, 2 times 3 halves is 3, minus 3 is 0. 0's on the bottom, and it's bad news. It's undefined. But for all other values of x, we can go run ahead because I've got a common denominator of 2x minus 3. I can just write it down here, and then I can just add the tops and the bottoms. And you know what? There you have it. That's the end of that problem, because as I look at it, I really can't do anything. If I wanted to, I could recognize that this is a difference of squares and factor it, but one way or the other, this is a fine answer, this is a fine answer as well too. Okay, so there's my smiley face over here. Next problem, not a happy situation because these two expressions have different denominators, right? And just to kind of compound things, I'm going to say, by the way, x cannot be equal to either plus 2 or minus 2. If it's plus 2, that's 0 and undefined. If it's minus 2, that's 0 and undefined. So with that, what the heck am I going to do? Well, the answer is I'm going to get myself a common denominator. It can be the least common denominator. I don't care. It just has to be a common denominator. And I'm thinking that if I make that common denominator, I'm going to make the common denominator hate to write things out. I'm going to make it x plus 2 times x minus 2. All right. So this denominator is x plus 2. What I have to do to this fraction right here, this first expression, is I have to multiply the top and bottom of it by x minus 2 times x minus 2. Okay? We've already told ourselves we're not dealing with the 2's. The 2's are out of the question. So this is a fine expression as long as x is not equal to 2. In fact, it's 1. Right? It's x minus 2 divided by x minus 2. So I've taken this expression, the original expression in the problem, and I've multiplied it by 1. So it's all good, right? We haven't changed anything at all. We just multiplied it by 1. And we've changed when I say we haven't changed anything, we've changed the denominator to a denominator that we're going to be able to make this second term look like, because I'm going to take this second term, x minus 2, and I'm going to multiply it not by x minus 2, but x plus 2 times x plus 2. Now, this term has, this is difference in squares, so maybe you should see this as x squared minus 4. And this has a denominator of x squared minus 4. So now I'm going to be able to conduct this division problem, this subtraction problem over the denominator x squared minus 4, or x minus 2 times x plus 2. So let's see what the heck we have. I've got a couple of binomials that I have to work out here, so I'm going to do that right here. I've got this common denominator going for me. Yeah. And now I'm going to multiply x minus 3 times x minus 2, and I'm going to get x squared times minus 2x, sorry, x squared minus 2x minus 3x plus 6. And then I'm going to subtract everything. I don't have enough room, do I? I'm going to have to come down here and do it, sorry. So here's my fraction. I'm running out of room on all sides. Here's x plus 2 times x minus 2 on the bottom. Up in the top, here comes x squared minus 2x minus 3x plus 6. And now be careful, I'm going to subtract everything here. So let's put that in a paren and go, I've got x squared plus 2x plus 4x plus 8. All right? So I've now combined these two problems over a common denominator. I've fanned everything out. I am ready to go ahead and simplify that and put it right here. Okay? So here I'm up at the top. I'm going to leave it like this and just do it, just so follow me. Here's an x squared here and an x squared there. X squared minus x squared. You know what? We got no more x squareds. I've got a minus 5x. Shall we do this in 2 steps? Let's do this in 2 steps. Here's a minus 5x. Okay? And then I've got 6x in here, but it's minus 6x. Okay? So let's put that right there. And then I've taken care of him and him and him and him. I'm just doing bookkeeping with those things, making sure I've got rid of everything, right? I've treated everything. And here I've got a 6 minus an 8. I've got minus 2. All right, and on the bottom, I've got x plus 2x minus 2. And I'm ready to, in the last step here, just say, well, I got minus 5 minus 6x. I got a minus 11x minus 2. All over x plus 2x minus 2. And for no particular reason, I would write that like this. But again, this is a perfectly good answer. And so is this.